Hello everyone. Today I am thrilled to share our innovative research journey exploring the intricate realm of language translation. My name is Tabia Tanjin and alongside me Dr. Mushfiq Anwar. Together we unfold the finding of our pioneering study titled Sylheti to Standard Bangla Neural Machine Translations, a deep learning based dialect conversion approach. Our abstract ID is 126. As we embark on the intellectual voyage, Efficience Bangladesh, a nation painted with diverse cultures and languages. Within the vibrant linguistics disparity, we notice a concerning shift in the use of the regional dialect, especially the Sylheti dialect. Today, our focus is the solution-driven approach to build the linguistic gap bridge, a neural machine translation system poised to seamlessly translate between standard Bangla and these culturally rich regional dialects. Why does our research matter? It seems from the critical issues of regional dialects, particularly Sylheti, being overlooked in the mainstream translation system. Our observation spotlight a glaring gap in the development of system dedicated to translating between standard Bangla and intricacies of Sylheti dialects. This negligence, coupled with a scarcity of effective translation tools, create a formidable challenges for speakers of those native languages, resulting in substantial communication gap. Let's dive deeper into the research gap that our works endeavor to bridge. Currently, there are a stark absence in the neural machine translation system designed effectively harmonize standard Bangla and Sylheti Bangla dialect. This gap is not communications challenges but also perceptualize the underrepresentations of these culturally significant dialects. Our objectives serve as a guiding lights in the transformative journey. Firstly, we aim constructive a comprehensive digital and structured Sylheti dialects dataset of Bangladesh, and these datasets serve as a bedrock of our machine translation models. Currently, we implement and access four sequential models: LSTM, GRU, by LSTM, and by GRU, exploring diverse approach to the intricate task of translating between standard Bangla and Sylheti Bangla dialects. Before exploring into the specific of our methodology, it is essential to acknowledge the relevant works that paved the way of our research. In the broader context, in machine translation systems in different language pair, Siddiq introduced an RNN for Bangla to English translation, incorporating context vectors for improved outcomes. Tiwari assessed natural machine translations models for English to Hindi translations with convolutional system to system models standing out. Carollo employed GRU based RNN for German to English translation, demonstrating effective translation capabilities. Furthermore, other studies utilize different neural architectures such as LSTM, GRU, by LSTM for various language pairs, providing a foundation for our exploration. In a more dialect-specific context, Arpita Goswami explores Sylheti grammar, offering valuable resources for understanding the intricacies of Sylheti dialects. Similarly, Hawk delved the Chittagangian language, discussing the grammar and punctuations which might bear relevance of our research on Bangla dialects. Nahid introduced a bidirectional transformation system for Chittagong utilizing binary search, word-to-word mapping, and morphological transformations. Hafizur diverse a conventional system for Chittagong language dialects employing word-to-word mapping, rule-based morphological transformations, and auxiliary word suggestion. These related works provide a backdrop against which our study unfolds. This is the methodology where we have done data collections, and after collecting data we perform some pre-processing tasks like tokenizations and paddings, and we train our models which are LSTM, by LSTM, GRU, and by GRU, and lastly we evaluate our model. Now, aim with the insight from the related works, let's dive into the malicious curations of our dataset. We extract Sylheti words and their Bangla equivalent from the myriad of sources, including national newspapers, social media, and voluntary comments. The resulting dataset comprises 600 parallel sentences in both Sylheti to Standard Bangla, thoughtfully organized in the tab delimit format. This standard Bangla sentence corresponding to Sylheti Bangla sentence is annotated by expert team of Sylheti peoples, and we allocated 95% for training and 5% for testings and 10% for training set reserved for validations. In model implementations, with our dataset in hand, we transition it to the implementation of our models. The backbone of our exploration comprises 4 sequential models: LSTM, GRU, by LSTM, by GRU. Each model follows a consistent architecture with nuances variations introduced for bidirectional models. This is the proposed architectures of our 4 models, and for performance evaluations we shine a light of the performance evaluations models, and to gain nuances insight into the quality and accuracy of the machine translation we employed wide recognized metrics BLEU and ROUGA's score. These matrices serve as a compasses guiding us through the intricate landscape of translations effectiveness. In our result analysis, we can see that our journey brings us the result and ensuring discussions. Among these models, the bi-LSTM model emerges a beacon of the promise and showcasing superior performance with the commentable BLEU score, which is 57.4%. However, our explorations reveals that challenges persistence. Translations accuracy, especially in capturing sentence nuances and maintaining grammatical integrity, remains an area demanding further attention. This realization fuels our ongoing research effort. And in this graph, when we compare BLEU score of those 4 models and row scores of those 4 models, we see that bi-LSTM and bi-GRU emerge as the potential candidates for highest accuracy in translating standard Bangla to Sylheti Bangla language translation. In conclusions, our Sylheti to standard Bangla conversion systems propelled by the powers of bi-LSTM models achieve impressive BLEU score, yet we acknowledge that our journey is so far from over. The need for more extensive Sylheti dataset is evident, and we emphasize the significance of future enhancement through the incorporations of multiple dense layers and meticulous parameter tuning. Our commitment extends to ongoing efforts, including the development of versatile dialect translation systems and the explorations of bidirectional speech-to-text and text-to-speech capabilities. These are the references we have used in the slides, and thank you for accompanying us on the transformative journey. I now open the floor for any questions or discussions that you may have. Your insights and queries are invaluable as we collectively explore the intricacies of our research. Thank you.